Hi, so this is Mr. Max. I am doing the cosine rule, which is another part of the series that I have on non-90 degrees triangles. Okay, so we're going to look at the cosine rule. The previous video has dealt on the sine rule. So let us talk about the cosine rule. So I'm going to start by bringing in a right angle triangle. Remember, the cosine rule has to deal with angles or triangles in a non-90 degree. But for the sake of proving this, I'm going to do the following. Right, so when you look at this particular triangle here, we see that AB is equal to C, the distance there. AD is X, that little bit here, and BD is represented by the height there. And we can also see that this particular angle is 90 degrees, as you can see by that little square that you have there. So when you use Pythagoras and you want to say what is the hypotenuse going to be, it will be C squared, which equals to H squared plus X squared. That is how you use Pythagoras. Now let me bring in another triangle next to it. And let's suppose we say this is triangle BCD. All right, so the whole thing makes one diagram ABC. And let's suppose the distance from here, from A to C, is B. Now, one of the things you should remember, perhaps, if I have to say that quickly, suppose you have a triangle, and let's say it's triangle X, Y, Z. You're given like that. So at the vertices, normally with our labeling, these are capital letters, all right? Capital letters at the vertices. So the sides are normally labeled, all right? The sides are normally labeled with small letters. So this is small letter X, and this will be a small letter Z, and this will be a small letter Y, for example. So opposite that, you have got that particular. At the vertex is a capital letter, all right? It's a capital letter at the vertex. And opposite that particular angle, you have got small letters. So this X here is small letter X. All right, so this is how the labeling is done, and it's exactly how that B was done. So you have got a capital letter B there, okay, and then here on opposite it you have got a small letter. So you have got a capital letter A here, but when you talk about the sides, it's small letters. For example, capital letter C at the vertex, and the side that is opposite that vertex, all right, has to be written or recorded as small letters. So you must never forget that. Right, so let's bring in some more things to our diagram that we have here. So what I'm going to bring in now is I'm going to bring in a distance from D to C. And hopefully you understand something a little bit better. Suppose this distance here is 10. That is the B distance from A to C. Let's suppose it's 10. And for some reason, let us say this here is 4. Then the distance here is going to be 10 minus that 4, which will give you 6. So that's all that I mean by B minus X, for me to find that particular distance, just so that you can make sure. Right, so we're not actually going to use those distances. Right, now let me take this triangle here, triangle CBD. This is 90 degrees here. And if you want to find A, you use Pythagoras. You say A square is equal to H square, all right, plus the sum of plus B minus X all square. And when you clean that up, you eventually end up with this particular equation here. So now I have two equations that I have. I've got equation 1 and equation 2. So what I'm going to do is I'm going to subtract equation 1, or I'm going to subtract equation 2 from equation 1. That means I'm going to say this A square, okay, equals to H square plus B square minus 2bx plus x squared. So that's equation 1. And I'm going to subtract equation 2 from it. C squared equals, right, equation 2 is then given to me as h squared, and then there's nothing in between, and then there is a x squared in it. All right, there's a plus x squared. So when I subtract the two from each other, you realize that you are going to eventually end up with something like this. You are going to end up with, on the left side, you're going to have a squared minus c squared, and here the h squares, they cancel, as well as the x squares will cancel. So you'll be left with b squared minus 2bx. Okay, I hope you can see that. All right, I hope you can see this particular case that I have here. So the only thing for me to do is I am going to make a squared the subject of the formula then. And the way you do that is you move that minus c. And then it's going to give you b squared plus now c squared minus 2bx. Okay, so I just want to show you roughly what is it that I will be doing whenever I bring my working down. So let me just remove this and bring in the versions that I have typed for you to see exactly what I have done there when I say subtract equation 2 from equation 1 and what I eventually end up with. So when I subtracted the two equations from each other, this is what I eventually end up with. And then I made a square the subject of the formula by moving that c square over. Now, the only problem, my formula for the cosine rule is nearly complete. I have a problem with that little x here. Okay, so now remember from our previous work, if you go to triangle ABD, this triangle here, and you want to find this x, you want to make x the subject of the formula, we use the cosine because cosine is whatever is adjacent over the hypotenuse. So cos is going to be cosine of A, the cos A is going to be x over c. All right, and when you have that, go ahead and make x the subject of the formula. So now I have got this x the subject of the formula. So I will use that value here, or the c cos A, and I'll replace it there where I have an x in my formula there. And when I did that, eventually I end up with a squared is equal to b squared plus c squared minus 2bc cos of A. Now, you do not really need to prove this particular formula. You just have to remember them somehow. So a squared is equal to b squared plus c squared minus 2bc times the cos of A. If it's b squared, it's the other way around. And if it's c squared, it's the other way around. The similarity you can see, the angle is always cos of A if you have a squared, cos of b if you have b squared, and cos of c if you have a c there. So the other ones here will be added the sum of the squares of what you don't have. So I have a c already, so a and b. I have the b here already, so a and c, and so on. So you have to find a way to kind of remember this formula when you're asked to use the cosine rule in order for you to find either a side or an angle. And you use the cosine rule when it's not apparent enough, or the information is not enough for you to use the sine rule. So I'm going to briefly bring in so you can see where do we use the cosine rule. Right, so the cosine rule is used primarily when we have a condition where we have two sides and they give us an angle that's included. All right, so let us look at a simple diagram. So what I mean here by the very first one here is you have got, for example, a triangle, okay, and you have got an angle here, let's say that's theta, and you have got the side here and the side here. All right, and this one here is when you have got all three sides of a triangle. When you have all three sides of a triangle given to you and you are supposed to calculate an angle, for example, that is when we will be using a different approach. So this is when we use the cosine rule. So when we have the cosine rule is when we have got a triangle, we are given all three sides. Then in that case, we can't use the sine rule, for example. Or remember in the sine rule, you could be given two sides, but the two sides don't necessarily, they do not flank the angle, okay, the angle is not included, it's not in between the sides, then you can't use the sine rule, then you have to use the cosine rule in order for you to find the missing information. So again, to summarize, when you are given two sides and you have an included angle, all right, then means you can find a side. Second scenario, when you're given three sides, that means you can find an angle. Okay, so we used to remember them at school as side, 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 and that was very helpful. Perhaps you can use the same. This is side, 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 and this one here, we used to remember the side, angle, side. Then we know exactly which the cosine is going to be the one that we're going to use. Right, so just to summarize then quickly, so you need to remember this: a square is equal to b squared plus c squared minus 2bc. It's twice bc, the value that you have here and here, twice of ac, the value that you have here and here. Another thing that worth mentioning is that this is representing one term, and you will see later on when I deal with that, I will be bringing some more type of nice questions where I'm going to use that. Right, so let's bring in a work example. So we have got a very simple case here. So I've got a triangle. So these little dashed lines that you see here are just to say that these are the sides. Suppose they give you the sides here, and you're supposed to find the third side. How are you going to write it using the cosine rule? Of course, you can use the small letter. You can say e squared equals to d squared plus f squared minus 2 times df multiplied by the cos of e. You can also use the capital letters, obviously. df squared equals to ef squared plus de squared minus 2 times ef times de times the cosine of e. Let's bring in another one. And you can pause the video so that you can maybe also work out. Here we are looking for RT. These two lines here means that sides are given and the angle is in between them. So what are you going to use there? Okay, so you will be using s square for you use the small letters. Remember, I said letter, small letter, obviously opposite that particular vertex. R square, small one here, all right, and plus t square, small one of that side. I hope you can get that. Or you could eventually also use the capital letters as I did here. RT square is equal to RS square plus ST square minus 2 times RS times ST times the cosine of that angle that you are given. So let's bring in an exercise. Right, so they are saying here we have got triangle PQR. And then they say angle R is 32 degrees, PR is 1.4, and OR is 2.2. Find PQ. You cannot solve this question if you don't bring in a diagram. Okay? Just bring in a triangle, doesn't matter. Then label it. Doesn't also matter how you label it. Clockwise, anti-clockwise, where you start. Now, just bring the information. R is equal to 32 degrees. You can see I put my 32 degrees. Then the distance P to R is 1.4. All right, and the distance Q to R is 2.2. So I have got that complete pair there. I have got an angle or side, angle, side. So in order for me to find the third side, all right, I have to use my formula. And my formula says you will take that, square that, and then you sum the squares of two shorter sides given, or the other sides given, minus 2 times the product of those sides, times the cosine of 32. Now you can punch that in just like that on your calculator, and you eventually end up with something like this. But remember, we're not looking for PQ squared, but we're rather looking for PQ. So to get rid of that square, we take the square root. And then you can give your answer then correct to the degree of accuracy that the question demands. In this particular case, I gave it to 3 significant figures as 1.26 meters. Right, so let's bring in a second question. So you have got a village here, and there are three features in this village that are standing out. There's a church, there's a school, and there's a bridge. And they are saying from the church to the bridge is 120 meters, from the school to the bridge is 86 meters, and then the angle SBC is 78 degrees. So you're supposed to find how far is the school from the church. Again, bring yourselves in a diagram, okay? And then write down the information that you are given, all right? You can see that I've got two sides and an angle in between them, side, angle, side. So I'm supposed to find school to church, all right? So again, that makes it easy for me. So I can find 86 square plus 120 square. Obviously, you clean that up, you arrive at 17,504 and so on. Now, what you need to do is you need to get rid of that square by taking the square root of that answer. And then if you give that answer to three significant figure, you get 132 meters. So when you don't have the diagram, it becomes a little bit challenging to do this particular question. So I'm going to look at this third question, which is particularly a very interesting question to me. It's a multi-topic question, and I like that. So I'm bringing in a little bit of algebra here. So I'm bringing in a diagram here, and as you can see from this diagram, D to F is 12 centimeter. Very important that you follow, I'm saying centimeter. E to F is represented by that quantity 5 plus X. Now, you can go ahead, if you don't like it, and you can go ahead and write it as nothing else as X plus 5. It is the same thing, all right? Because both the terms are positive. Just to make sure that you don't end up making mistakes somewhere along the way. And then they're saying ED or DE is represented by X. So what we are saying here is you're supposed to form an equation in terms of x using that x, and you're supposed to show that that equation reduces to 3x squared plus 15x minus 119 equals to 0. So we are trying essentially to use this information and get to that quadratic equation there. So this is a very interesting question, and it's typically things you will find in your examination. So we have to do it step by step. Let's take the information that we know. We know the 12 square is opposite that cos of 120. And x squared is going to be the two other ones that you have there. All right, minus 2x times x plus 5. Now I'm going to bring in a little bit of work. The x squared that you have here plus 10x plus 25 comes from x plus 5 whole squared. The negative a half you see here, that is the cos of 120. Okay, but I put it in brackets because it means it's still part, and it's very important that you understand that you don't make that mistake, right? This minus a half is not a term on its own. It is part of this particular term that you have here. That is very important that you understand that. All right, because you'll see that I try to show it step by step as I go along. So I introduced a little bit of square brackets here. So I took that negative a half and I just multiplied by the 2 that I have here because it's very easy for me to do that. Then when I do that, I get 2 times negative half is negative 1. Okay, so I'm first trying to sort of finish this term and get it all done. And then I multiply x, the negative x with that x gives you negative x squared, and the negative x times that positive 5x give you minus 5x. But it's still subtracted though. Can you see that? Right, so from here, the subtraction sign will definitely change everything. It changes this to a plus, it changes that to a plus. So now what is left is to collect the like terms that you have there. So 2x squared plus x squared gives you 3x. And then you have 10x plus 5x gives you 15x. Bring that 25 down. Now we just have to get rid of the 144 because quadratic equations should always equal to 0. And when you clean that up, you eventually end with what you have, which is 3x squared plus 15x minus 119 equals to 0. So there is a B part to that question. They are simply asking us here now to solve this particular equation, right? It's a quadratic equation, so I'm going to go ahead and I'm going to use the quadratic equation formula. So let me bring that back, and I highlighted what the value of a is. A is positive 3. Remember, it's the one in front of the square term. The b is the middle one here, positive 15, and minus 119 is the value of c. So when I plug that into my formula, I'm going to get eventually with two solutions where x is 4.28 or when x is negative 9.28. There are previous videos that you can go through in algebra in my YouTube channel where you can find out how to solve quadratic equations. But you should be familiar with solving quadratic equations of this type where they ask you to give your answer, for example, to two decimal places, either by using the quadratic equation formula or by completing the square method. Now, they are saying here we're supposed to find the length of EF. So let me bring that diagram in here. So we're supposed to find the length of EF. Now, this measurement of negative 9.28, it will not be applicable here. Because if you punch this in for x, you're going to end up with a negative answer. And a distance cannot be negative. So the only viable one is the 4.28. So when I add that 4.28 or 4.276, right, I get 9.28, adding it to 5 plus x. Now I get 92.8 millimeter because this is still in millimeter. All right, or it was in centimeter, 9.28. So in order for you to change centimeters, you multiply your answer by 10. Okay, and 92.8 millimeter to the nearest millimeter is nothing but 93 millimeter. So this is a very interesting question, and I perhaps will advise you to pause the video, have a look at the particular question. Right, when we are supposed to find an angle, and this is very important. So what I do here is I am going to make cos A the subject of a formula in order for us to find this, because now when we find an angle, we cannot use the same formula, all right? We have to make cos A, cos B, or whatever that angle, the subject of the formula. You can ultimately also punch in your values here, and then you rearrange, and then you still go ahead and find the cosine of that angle. But it's also nice to know what the formulas are. Right, so when I make cos A the subject of the formula, the first thing is I'm going to move this term, the minus 2bc cos A, I'm going to move it to the other side so it can be positive. It's very easy and better for me to do that. All right, so the objective is to make cos A the subject of the formula. All right, so the next thing that I'm going to do is I'm going to take away the a square here, and I'm subtracting a square from both sides, from the left side, all right, moving it from a square to from the left to the right as I did there. Then the next thing is I must get rid of the minus or the 2bc that I have here. And the way you get rid of that 2bc is you simply divide both sides. When you divide both sides, then eventually you will end up with cos A equals to b squared minus c squared minus a squared all over 2bc. Now, in order for you to remember this, again, a here and minus that a squared. The a and a go together. So other ones I added the squares and then minus the a with whatever that angle is, the side opposite that angle. So the same applies when you have a letter b, for example. So I'm going to minus b squared, all right? And then I take the sum of the other squares divided by 2ac. And c here minus c squared here. Then ab squared or a squared plus b squared times 2ab. So you have to figure a way to remember this. But if you don't, go ahead and use the cosine rule. If you remember it, plug in the values and then make cos A or solve for cos A. Right, so let me bring in a question. So I have got a question here. They are saying triangle KES, rather. KE is equal to 12, ES is equal to 7, and KS is equal to 8. So I've got three measurements that I'm given, all right? And I just punch in, draw any type of triangle, and then you can punch in. So they are asking us to find this angle here, and I represent it by my theta that you can see there, all right? That angle theta there. Or I could easily have said angle KSE, but I do not want to go so long, so I will just use angle theta there. So in order for me to find that angle theta, and remember also very important that this diagram is not to scale. It's just a sketch. And it could be that this angle is an acute angle, or it could be that this angle is an obtuse angle. All right. The diagram just helps me to fill in the missing information so that it's easier for me to determine what am I supposed to calculate, or with respect to which point or which vertex. So cos theta is, remember I said, whatever is opposite that 12 squared or 12 squared, you subtract that. All right, so 7 squared is 2, the flank the angle, plus 8 squared minus 12 squared over 2 times 7 times 8. Well, you get this. Now, what is important is, now we are supposed to find the inverse because we want theta alone. And to do that, you bring up your calculator, okay, and you're going to find the inverse sign button. So you have to press shift if you have this type of Casio calculator. The shift tells you must sort of bring out that color that is there as a second function. All right, so shift inverse sin, and then you press this business here. Okay, so that inverse, not sin, but inverse cos rather. All right, so I'm now saying inverse sin, inverse cos. All right, so when you have that, then you can punch in the stuff. You should be able to make sure your calculator is in degree mode. Sometimes it's written here on the display of your calculator. It's either a D or a DEG for degree. Okay, so you should get 106.0, so on and so on and so on. And then you can give your answer to 1 decimal place like I did here. So very important that you realize that you can't solve the question without bringing in a diagram. And because you are calculating an angle, you are supposed to now use the inverse of the cosine. Right, let me bring in another question 4 here. Again, question is particularly maybe difficult for some learners because it's a word problem, and there are some words that you might find a little bit difficult. Like, what does it mean that point P is 32 meters due north of Q? It simply means it is exactly or directly north of that. Okay, so when I bring in a diagram like what I did here, see point P is exactly north of that. All right, so I can now, after drawing the diagram, I can now complete the information. So I know that Q to R is 21, P to R is 19, and PQ or QP is 32 meters. Now, they are saying here, and this is the part, find the bearing of R from Q. So that means you go to, after the word from, so you go to Q, the bearing. The bearing means we're looking for this angle, and once we have this angle here, then we're going to write it as a 3-figure because it's supposed to be a bearing. Suppose it is a 2-figure, then we have to put a 0 in front of it, but we'll get to that part of the answer. So this is the particular angle we're looking for. So again, we then use cos Q, which is equal to that 19 square is going to be subtracted. Okay, that's maybe the first thing you can write in the moment you have something like that. And the other ones, just add the squares and 2 times the sum of, or the product of 21 times 32. Well, you're getting a positive ratio of 23 over 28, and now you have to find the inverse. Remember now to grab your calculator, and then you calculate that particular value. So angle Q, therefore, is 34.7 blah, 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 blah degrees. But we're not calculating the angle. All right, we have to write it as a bearing. So when you write it as a bearing, you put a 0 in front of it. So the bearing of R from Q is 034.8 degrees. Right, so this brings me to the end of this particular series on trigonometry. So don't forget to subscribe to my channel, and there are going to be more videos on trigonometry, and you can find and download so many of the videos that you have because I'm making them public. Use this when you prepare for the examination.